Hello everyone. So in first part I have explained all about this conductometry, that is type A, type B and type C, and now these classifications are there. So titration in which sub change in the conductometry at the end point, and or you can say determination of an endpoint of titration by means of conductivity measurement is called as conductometry titration. So types, there are four types mainly. One is acid base titration, displacement titration, precipitation titration, and complexometric titration. So let's see one by one. During the course of the titration, the conductivity of solution changes because there is change in the number and mobility of ions, and at the end point of the titration there is a sharp change in the conductivity of the solution, shown by the intersection of the lines in the graph of conductivity versus titrant added. I will show you. And apparatus required is titration vessel, stirrer for mixing, manual or automatic burette to deliver the titrant, and conductivity meter, conductivity cell, and conductivity is measured in millimoles of or you can say micromoles. The first one, that is acid-base titration. In acid-base titration, again we have four divide. We have divided it in four parts. And titration, for acid-base titration, the first one is strong acid with strong base. So titration of HCl, that is strong acid with a strong base, that means sodium hydroxide we are going to take. You can see the reaction here I have given, where the HCl is reacted with sodium hydroxide, and there is a formation of NaCl and removal of water. So you can see the graph here. This is the equivalence point we get here. And one side will be conductivity and another one is volume of sodium hydroxide. And then we have strong acid with weak base. The first one we have taken is strong acid, strong base. Now we are taking strong acid with weak base. So for that we are taking this HCl, and next for which is ammonium hydroxide. Here you can see the reaction. Ammonium chloride we are getting, and one water molecule, and almost horizontal, since the ionization of this ammonium hydroxide is prevented in the presence of ammonium chloride formed during the neutralization, and equivalent point here you can see. After that we have acid-base titration. The third one is weak acid with strong base. So first we got strong acid and strong base there, and after that we have reacted with strong acid with weak base. Now it's weak acid with the strong base. So here you can see the reaction, the titration of CH3COH with NaOH. You can see here, due to slow salt formation, the curve is bent here due to excess addition of sodium hydroxide, and ultimately we are getting the equivalent point and volume of sodium hydroxide added. Here we can see. And the last one we have weak acid with weak base. So titration, here you can see the reaction. Weak acid we are taking CH3COH with NH4OH. We are going to react, and we got this trait due to the suppression of titrant, and this due to increase in the salt formation, and we got the equivalent point here. You can in the middle here the band is there. So volume of NH4OH added, and in y-axis the conductivity will be there. And other classifications I am going to explain in my next video. Thank you.